Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 437, length of the longest reshaped diagonal segment. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. I think this one, I actually find it a little bit surprising that only 450, how many people got, oh, that's not, I have a screenshot so that I could keep the sizes different, but, I don't know. It's actually a little bit awkward, but yeah, this one I didn't think was that hard. I think the trickiest part is that implementation, right? I think the idea is straightforward in that this is just dynamic programming. I think one thing that you have to be a little bit careful of, especially with problems like this, is that let's see. Yeah, okay. Oh no, that's Java. Yeah, 4 seconds is actually a little bit slow still. Is that is choosing to do it top down or bottoms up? And honestly, for these, I almost never know because a lot of the reasoning is because Leetcode does use this thing called sum of execution time, and the sum of execution time, you just don't know how many test cases you have, so you can't even test for it because the max case is not like passing the max case is not indication enough that you'll pass the thing, so I never know. So I did convert this to Java at some point, but after it worked in Python. It's just that I wanted to practice doing that because it seems like I've been needing it a lot. But yeah, so the idea here is just dynamic programming. You could also do it bottoms up, as I said, but the thing is that a lot of states are not possible, right? Depending on how you define your states, which we'll go over. So that's why I kind of yeah, that's why I kind of did it this way. Though actually, now that I think about it, I could probably even reduce this a little bit more, the states. But we'll go over it together. We'll do the state reduction live. And yeah, the one tricky thing, there are a couple of things that are tricky. I think the idea, once you mention it, is not that bad, but implementation is always a little bit tricky. And the thing that I worried about was just making sure that we can only go counterclockwise. And also just showing which counterclockwise is, and I'm glad that they did have a diagram, even though this is a very confusing diagram, honestly. I thought I was doing some kind of spiral or ninja star or something like that. Also, wait, is that like... Am I like being a little bit nuts? Is that like... Oh, Leetcode, I didn't see this before, but... I mean, Is this literally a swastika? Oh my god, Leetcode. What the... Come on, man. Okay, sorry friends, I had to compose myself a little bit because come on, Leetcode. Especially at this day and age, are you serious? Okay. I'm clearly naive and a little bit slow because it took me this long to realize. But in any case, my apologies for the pause. It's what a silly time. Okay, but yeah, you can only go clockwise. Is this problem, right? So here I made sure that we only have 4 directions that we care about, right? The diagonals, and then also that we only go clockwise. And the way that I set it up is so that if you go from D or the direction I to I plus 1, it will be clockwise. That's how I would normally set it up in general. Sometimes I go the other way, but it depends on the problem. It depends on whether it matters. This one, it really matters, so you have to be really careful. And then after that, it is just, dynamic programming, as I said. There are a couple of pieces, right? One is to just start off at the number 1, right? So if it's number 1, then, yeah, the answer can at least be 1, which is nice. And then now... There are a couple of ways you can kick this off, but the way that I chose to kick it off is this way. And it's just that... you have dx dy, nx, ny, right, for the direction. Hopefully this part is straightforward. This is just the next one. And because we start with grid value is equal to 1, then the next one has to be 2. So then we just double check if it's 2, then If it's 2, then it's going to be 1 for the current one plus the whatever, right? Plus the recursion. And we'll go over the states and the recursion now. The reason why I set it up this way is just that, I don't know, it's just a little bit cleaner, I think, right? And what are the states, right? You have X, goes from 0 to Y, 0 to C. I think this part, hopefully, if you're watching this, you get it. Use this if we have used the turn yet. And then last is the last digit we care about, or last number, the last grid number we used or care about. And then D is just the current direction, right? And we'll go over it like this, right? And because we already took out the 1, we don't care about ones anymore, so we can do this part just thinking about it. Because then now last is going to be also, in this case, because we took over 1, it's going to be either 0 or 2, right? So that's why I have this thing, because it go from 0 or 2. Okay. And then now the only 2 things you can do, it's almost like a take no take, right? This is keep going is this part. I put the comment here, but keep going is this part. So we have the direction D, we keep going, we go to the next one, check to see if it's inbound, and also have the correct grid signal or grid number, and then we add 1 to it, right? Keep in mind that the base case is that this is already a rounded square, so best is actually you go to 1. It's a small distinction, but it's very easily missed. Okay, and then we also try to turn right or clockwise or whatever you want to say. If it's not used, then we try to turn right. This is just, everything is the same except for that here in the states, the new state is that we already turned right. We have a new last number, and then this is the new direction, right? And that's it. Pretty straightforward. There's only 2 operations here, with, all of 2 times O of 1, if that sounds a little bit better, I don't know. And so so that's going to be in 1 core. That's going to be really fast. But how many cores do we have, right? Well, X is going to be 0 to R, which is equal to 500 max. Y is 0 to C, which is also 500 max. Used is 0 or 1 or Boolean, really, if you want to say that. True false, which is 2. Last is 0 to 2, or 0 or 2 actually, so also 2. And then D is actually equal to direction, which is 4, right? So if you kind of just multiply them up, you will get 4 million, which is fast enough, I suppose. But actually, honestly, I would be worried and cutting it tight. But I still YOLO as I kind of implement try to convert it to Java while I have this. So the thing about this now though is that and this is just now, or like a little bit earlier when I realized, is that last is actually, the way that I use last is actually the current digit, right? Because the way that we set up the invariant is that xy, or grid of xy, is going to be equal to last. So you could actually just directly go and then take this out, and that's it. And wait, let me see if I'm not lying about this one. I might have to take some. Oh yeah, here we don't need this anymore. We don't need this anymore. In theory, it should be a little bit faster, but maybe not super faster. We'll explain why in a second. So it went from 4.1 to 4. So actually, I thought it'd be a little bit more faster, honestly. But the reason why it isn't faster. The reason why I would think it's faster is because now you have 1 fewer parameters and just less storage space, and you save time on the storage. But the reason why you don't actually save that much is because, as a result, last is equal to grid, right? That means that last is uniquely determined by grid. So that means that, for example, if grid xy is equal to 2, then the input can never be where grid xy is equal to 0, right? I mean, obviously this is literally just what we said, but what that means is that if you look at how the space is allocated, that means that half the numbers will never be possible, meaning that when we had last, we would never core it with 0 with the same x and y. And so as a result, the number of states, even though our analysis is a little bit tighter, the code actually runs at the same speed because that number does not like add an extra dimension because there's no variation on that number. So yeah, so that's pretty much it. And once you realize that, then this is only 2 million, which I guess is a little bit better. It's not. Is it all the best? No, but enough to YOLO, and apparently it was good, which is nice. But yeah, 2 million times number of these, and it should be good. And there is a lot of self-filtering, of course, because this only happens when this is 1, right? So you don't kick it off that much. But that's not on a worst case scenario. That's just on the test case of Leetcode scenario. So I wouldn't think that much about it. And yeah, that's pretty much all I have for this one. Let me get a little bit smaller. This is my 100% font. So yeah. I guess you could fit everything, even though you may go need glasses for it. But yeah, so what's the complexity here? As I said, it's going to be R times C times 2 times 4. So 8 times R times C, or linear time linear space. Linear being, of course, the size of the input, which is R times C, right? And that's it. Let me show you the code again, but from here so that you could, just actually see it. This is the DP code. This is the kickoff code. And of course, if you want to make sure, this is the directions that I have. And that's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me solve it live during the contest now. Or during timeout? Okay. Today's a struggle. How many people got all solved? Wow, 2,000. I'm just having a rough day. Alright, we have half an hour. We'll see. The top people, well, I don't reckon. Okay, Uri got in 12 minutes, so maybe double that time for me would be reasonable, expectable. I don't know. Alright. Each element is 0, 1, or 2. What is going on? Oh, wait. So we have a grid. Okay, we have a grid. 0, 1, or 2. Okay, so we have a grid. I'm trying to rush it a little bit. This starts at 1. Huh? Start at a longer diagonal. Oh, I see. Reshape. This is like the most confusing graph ever. But okay. And you can make a clockwise turn. So okay, but that's fine. It's just prefix some in a harder way. I don't think this is that hard necessarily. Whether I get it right is another story, but I don't think this is that hard. Do we always start at 1? So it starts at 1 and then it goes 2, 0, 2, 0, right? What is 500 squared again? The thing is that I know I could do this top down, but I feel like Leetcode is going to time out on it, so it's just silly. Like it's going to be sad. We'll see. I mean, at this current point, it doesn't even matter anymore. So here, let's go 1, 1, and then counterclockwise would be -1, and then no, and then 2, which is -1. Nope. -1, -1, and then okay. Hope this is right, but at this point I don't know that I care that much. But yeah. Yeah, I don't think this is that hard. I'm just kind of confused as a result. And there's actually some states we have to do, but I don't know. Right, something like that. Maybe I should do this way. Maybe that's fine. The states are actually, there are a lot of states. I might have to do it too. Like, I definitely feel like I have to do it in Java, so I have to convert it to Java later. But that's fine, I suppose. Because then this would be, was it 2 first? Okay. So now we go there. We haven't turned yet. Last digit is 2. And the direction is I. Same thing, yep. That's a lot of states, actually. I mean, a lot of them are not going to be used. So, but still, it's a lot of state. Okay. You probably could pre-process this, is what I'm thinking, but I don't know. Okay, it's just take no take, right? Is this +1 actually? No, right? So, okay. Just keep going. We want this to be 2 minus last, so it swaps from 2 and 0. So if that's good, then we just keep going, right? Otherwise, turn right. out of range because I suck at I can't even write if statements anymore. I don't know how I missed this. I'm just so tired. 5, 3, 5, 1. All right, we're almost good. Not actually good though, which would be nicer. Okay, so we have this one. Yeah, okay, fine. Is this fast enough? I actually don't know. But at this point I don't care anymore. Leetcode rating is a sham. Also I suck. But okay. So alright, so we have here, we want to start at, so ideally it is 2, 3, 2, 3. Am I doing it well? 2, 3. I have to add an I, maybe. 2, 3. We want to go that way. That's plus x minus y, plus x minus y. So that's 1, right? But 1, 2, 3, and then 3, 2. Okay. So that's already 2. So what's 1? This is really annoying, actually. Okay, no, I'm just trying to think. That's I need to print out directions. Oh no, I already do. It's just order at the end. 4, 1. This is the one that we care about, I think. It goes to 3, 2, right? 2, 3 to 3, 2, 4, 1. Okay, that's fine. 3, 2, 4, but it doesn't do the turn to 2, 2, 1. I want to see it turn to 2, 1. It's just because I'm bad and I forgot to do this. I wrote it in the thingy, but then I was wrong. So okay, so that's a good catch actually. It would have been really sad to alright, let's just real quick to get it wrong. Okay, because that's just a bad typo. Well, I don't know if it's typo, but it's still pretty bad. Is it going to time out now? I don't know. Let's hope not. I'm going to already convert this to Java. Oh, well, that's a surprise actually. Yeah, I don't know. It's kind of tricky because I don't think that was a hard problem. Actually, I mean, if you look at my times, that was my easiest problem. Well, other than Q1, obviously. So I don't know. I'm just having struggles today. But yeah, because Q4 was pretty okay. But what's Q3 again? Oh, this one. Yeah, I just kind of like I made an observation that I was wrong about, and Q2 as well. I just kind of wasn't really thinking about it. It is what it is, I suppose. You go through stretches like this, and yeah, and we have 20 minutes of penalty, so it's gonna be very sad until until that happens. What is there to say? I mean, Q4. let's actually double check real quick. Oh, actually 4 seconds not that bad. I thought it maybe was, honestly. I even had the Java solution. Well, I already did it because I didn't care about the penalty, but because I already struggled it. But and this. I don't know that this is fast enough because it uses cache. It uses a string as cache. But I am just curious for science. Yeah, I mean, I'm actually not surprised, but I think it's just because of this thing, honestly. Because that thing is always a little bit awkward. Huh, time limit, I expected memory limit actually. Maybe, I don't know. It's definitely just very awkward in general. Ooh. Oh, because I have a -1 somewhere. This is just wrong, right? Oh, no, because it maps on the last -1, but the last actually do. Is it? Actually, I think this is like really weird and awkward, but I see. I know what they're trying to do, but yeah, maybe not. Kind of funny, actually. This is the time where if I actually did do it this way, it would have been really sad. Let's see if this is fast enough. Ooh, wrong answer. I mean, it's kind of funny because, well, I mean, I don't know. I didn't really look at this code, so it's possible that it's just doing crazy things, right? 2, I guess this actually makes sense. I actually don't know why this is wrong per se. I don't think there's any longs, like overflows, underflows. Probably don't need this anymore, but actually, no, I don't know why this is wrong. I mean, I probably could guess it, but X, Y. Oh, because it got rid of used. Come on, ChatGPT. Come on, ChatGPT. How do you get rid of a variable? If it times out, then but okay. I don't know. So it would have cost me something if I converted to Java. Just well, maybe I would, because I don't think I would have debugged these. Well, the string one I would have tried to convert it, but then the wrong answer I might not have noticed. But yeah, it's just much faster, right? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye bye.